Another day, another story. Get ready to get your mind blown as we explore 5 crazy facts about time dilation from Einstein's bizarre theory of relativity. You'll find out how time is not as absolute as you think. Don't forget to subscribe to Europa Facts for more exclusive science fact videos. Time. We take it for granted that time flows universally the same for everyone everywhere. Second by second, minute by minute. My watch ticks away at the same rate as your phone timer and the big clock in the town square. But what if I told you time itself can speed up, slow down, and get distorted? That two events happening simultaneously for me are observed happening years apart by someone else. Sounds unbelievable, right? Well over 100 years ago, Albert Einstein shocked the world when he revealed that time is not actually absolute. His revolutionary theory of special relativity shows that time can dilate or stretch depending on how fast you are moving relative to another observer. The faster you go, the slower time passes for you from the perspective of someone standing still. This bizarre phenomenon has been proven many times with atomic clocks on jet planes and satellites. Particles moving at near light speed barely age at all. And gravity can dilute time too, an effect known as gravitational time dilation. Mind blown. Here are 5 incredible facts that reveal the flexible, relative nature of time in our universe. Before starting video, we warmly welcome to our newly coming subscribers. We show 2 new subscribers in every new video. You can be the next one by subscribing and commenting on our video. Fact 1. Time dilation allows time travel to the future. So first up, the most trippy implication of Einstein's time dilation is that fast movement or strong gravity can act as time machines into the future. Time dilation means astronauts orbiting Earth on the International Space Station age slightly less than us on the surface. GPS satellites have to account for tiny timing discrepancies due to time running slower up there. After 6 months above, an IS astronaut has time traveled just 0.005 seconds into Earth's future. But more extreme relativistic effects happen approaching light speed. Say you take off in a hypothetical near light speed rocket ship, accelerating to 99.5% the speed of light over 670 million miles per hour. To you on board, your clocks still seem normal and 1 year passes. But to observers on Earth, over 70 years zoom by. Congrats, you just time traveled 69 years into Earth's future. Incredibly, astronauts can return to Earth decades later while hardly aging at all. Of course, actually reaching such velocities requires enormous energy and high-tech materials to withstand particles bombarding the ship. But just remember, science says fast motion can propel you along Earth's timeline faster than clocks normally tick. Groovy indeed. Fact 2. Muons prove time dilation is real. Now I bet some of you still don't buy this warped time stuff. But we have definitive proof that time dilation is real and measurable from an experiment with particles called muons. Muons are unstable subatomic particles created when cosmic rays hit our upper atmosphere. Traveling at 99.9% the speed of light, they should only last 2 microseconds before decaying. But detectors show many muons make it all the way to the surface before disintegrating an extra 500 microseconds from their perspective. How is the several kilometer trip possible if muons last mere millionths of seconds? Time dilation saves the day. To the muons, the near light speed journey takes way less than 2 microseconds thanks to dilated time. So they survive the whole descent. This confirms time really does slow down for speedy particles, exactly as Einstein's equations predict. Suck on that, physics skeptics. Fact 3. Atomic clock experiments prove time runs slower for moving clocks. Fact number 3 dives into cool experiments that precisely measure tiny time warps from motion. How do scientists reliably test Einstein's time dilation idea? By comparing 2 perfectly synchronized atomic clocks, having one move very fast then checking if their times stay matched. Atomic clocks use exactly oscillating electrons to achieve better than nanosecond accuracy. In 2010, 2 such recorders had their times matched, then one took to the skies aboard a jet for hours. Upon landing, the airborne clock was 59 billionths of a second behind its stationary twin. Precisely what Einstein described 100 years ago. Since then, many recreations have validated that moving clocks tick slower relative to stationary ones. GPS navigation actually accounts for satellite atomic clocks drifting behind surface receivers by 7 microseconds daily. Tiny differences that absolutely prove time is not the rigid illusion we thought. TikTok, time is an elastic concept. Fact 4. Gravity also stretches time itself. Alright, now if you're not already reeling from time's newly flexible status, we are going full physics freaky with fact number 4. Turns out gravity itself can slow the passage of time in a phenomenon called gravitational time dilation. Say what? Just as motion influences time flows between observers, height in a gravity well impacts how quickly seconds tick by. Case in point, the aging rate between our feet versus head is ever so slightly faster due to Earth's gravitational gradient. Okay, not enough to worry about wrinkles. But it shows that gravity dilates time too. And the effect is measurable when comparing an atomic clock at high altitude to one at sea level. After just 1 year, the mountaintop timer is around 90 billionths of a second ahead. Tiny yet clear evidence of gravitational time warp. For something more extreme, gravity causes 100,000-year-old clocks detected from a black hole's accretion disk to run over 30% slower than Earth clocks. Absolutely mind-bending how mass can literally warp space-time itself. Fact 5. Twins paradox: age gap between twins after relativistic space travel. Finally, fact number 5 explores the most famous conceptual illustration of time warping, the twins paradox. I promise it's not actually a paradox but rather a logical story that reveals the subjective flow of time. The setup: one twin astronaut rockets close to light speed to a distant star while the other stays on Earth. On returning, the space twin has only aged say 5 years due to high-speed time dilation. But shockingly, decades have passed on Earth from the stationary twin's perspective. The reunited siblings now have vastly different ages. Wild. While no actual twins have done this, the thought experiment above shows how relative velocity can make identical clocks go out of sync. Two twins sharing the same lifespan path diverge across separate time streams based on their motion. What's in the past or distant future for one, is present to the other. Time definitely seems a lot more pliable than our instincts assume. Well, I hope I successfully melted your brain with those 5 mind-bending facts about Einstein's time dilation. From using relativistic rockets for future time travel to experiments proving moving clocks tick slower to the twin paradox illustrating crazy time gaps from space travel, we saw that time is not the rigid universal constant we assumed. Seconds can warp and bend based on your speed and gravity. A century ago, Einstein overturned millennia of assumed temporal absoluteness. So remember, time is relative, baby. Don't forget to smash that like button if you enjoyed this dose of physics. What other mind-blowing science topics should I explain next? Let me know in the comments. And subscribe to Europa Facts to unlock more exclusive content about our amazing universe. Catch you in the next video, Space Rangers. Thanks for watching.